Hello, dear students. Today we will discuss a very interesting and important topic in numerical analysis, that is interpolation. So before going to discuss what is interpolation, let us consider a simple example. Say y is equal to fx is equal to x square. So this is a given function, y is equal to fx is equal to x square. So if we consider this function and corresponding to that function, so we consider the data. Say this is x and this is y, right? And in these functions the variable x is independent and the variable y is dependent. So as x is independent, we consider any value as per our choice. We consider x as 1, x as 2, x as 3. Once we consider x is equal to 1, the value of y is 1 square, that is 1. When we consider x is equal to 2, the value of y is, that is 2 square, that is 4. When we consider x is equal to 3, the value of y, that is x square, is 9, right? So this is very simple because the given function is given, right? So whatever input data you consider, corresponding to that you can get the value of y. I am giving another example. So this is x and this is y, right? The function is not given but the data is given. Suppose 5, 7, 8, 15, 9, 28. So these are the set of data. Corresponding to 5, the value is 7. Corresponding to 8, the value is 15. Corresponding to 9, the value is 28. Then my question is, can you say if the value of x is say 10, what is the value? No, we cannot say, because from this we are not able to study the pattern or the function y is not given, right? So here the function is given, for x we can find the value. Here the data is given, but by studying this data from x we cannot say y, but that is our requirement. In interpolation, what we will do, we will develop some techniques that if a set of data is given, by studying that data for a given x, we can find y. Right? So that technique will be discussed in interpolation. That means without knowing the function, we can find the value of fx for a given x. Okay. So now what exactly interpolation say, let us discuss through one example of a graph. Suppose we consider a graph like this with axis x-axis and y-axis, and x0, y0, x1, y1, x2, y2, etc. up to xn, yn are the set of data points, and corresponding to that set of data points we draw the graph like this, right? We do not know the function, but from this set of data we draw this graph. For the time being, suppose we consider this graph is fx, but fx is not known, right? Then this is the point x0, y0, this is the point x1, y1, this is the point x3, y3, this is the point x4, y4, and this is the point x5, y5, right? Now somehow by using certain techniques we will try to generate a new function, and that new function will be called as phi x, such that phi x satisfy these data points. So it will satisfy this x0 y0, x1 y1, x3 y3, x4 y4 and x5 y5. Suppose the graph is looking like this, right? So this graph is phi x and this graph is fx, right? Fx is not known, but we are able to design the function phi x which matches with fx at the given data points. Then this phi x is called interpolating function because phi x matches fx at the desired points, and the process by which we find phi x is called interpolation. Right? That means set of data will be given, but we are not known what is the function fx, but we are designing a function phi x which satisfy all the given data points, and that function, the function what we designed, that is phi x, will be called as the interpolating function. Right? And the process, the technique by which you design phi x, that is called interpolation. And what is the advantage of this? By this process, for a set of data points, when the data points are given, by studying that we can find the value of y for a desired x. That is our main motto of the interpolation. So now we discuss that actually what one interpolation is. Then we will discuss the types of interpolation. In the types of interpolation, we will classify it into two types, right? These two different types are the interpolation for equally spaced data. Equally spaced data and unequally spaced data. Unequally spaced data. Why we categorize the interpolation in these two forms? See, previously we have discussed that from a set of data points which were given, from that data points for a given x we are finding y. What is x? X is independent variable. So when we design this x and y, this x and y, we decide this x. So this value may be equispaced, may not be equispaced. Suppose we decide the value of x as 2, 4, 6, 8. That means they are equispaced. So that type of, and for that type of data we find y. So that comes under the head equally spaced. But if x we decide 2, 5, 4, 9, randomly we select, then for that x the value of y will be unequally spaced. We will come in detail with the examples. And when the data is equally spaced, under that head we come across two types of interpolation problem, that is Newton forward interpolation and here this is Newton backward interpolation. And in unequally spaced we will discuss two types of problems. One is Lagrange interpolation and other is Newton divided difference interpolation. Okay, so we will come across these four types of problems: Newton's forward interpolations, Newton backward interpolations, Lagrange interpolation, and Newton's divided difference interpolations. Right, these two comes under the equally spaced data, these two comes under unequally spaced data. Okay, so now we will discuss, out of these four types, we will discuss what is Lagrange interpolation and how we work out the problem under Lagrange interpolation and why it comes under this unequally spaced data. Now we will discuss the Lagrange interpolation formula. Lagrange interpolation formula. So first thing is, it is used in case of unequally spaced data. Unequally spaced data. Okay, that means the value of x which will be given in data, that should not be equally spaced, means the difference should not be same. Number 2, it is suitable when number of data points are relatively less. Means this formula is suitable when the number of data are less. If the number of data will be more, this formula we can apply, but it will not be suitable, it will be very lengthy one. Okay. Then what is the formula? The Lagrange interpolation formula, that is Lx. Lx is equal to, you see how I am writing, x minus x1 into x minus x2 up to x minus xn by x0 minus x1 into x0 minus x2 up to x0 minus xn into y0 plus x minus x0, x minus x2, x minus xn by x1 minus x0, x1 minus x2, x1 minus xn into y1. Like this we will proceed, and the last will be x minus x0, x minus x1 up to x minus xn minus 1 divided by xn minus x0, xn minus x1 up to xn minus xn minus 1 into yn. And from where we get this result? Where set of data points are x0 y0, x1 y1 up to xn yn, and the values x0 x1 x2 are not equispaced. x0 x1 up to xn are not equispaced. This is the formula. You see how you remember this formula, though it looks lengthy, but it is very simple and easy to remember. You see, what are the data points? x0 y0, x1 y1 up to xn yn. This x0 x1 up to xn are the independent variable in the given data. You see how we are writing the first term. First term we are not considering x0. we have to find the value of y at x. So what is the formula? We are writing x minus, we are leaving x0 and we are subtracting every xi other than x0 in the first term, x minus x1, x minus x2 up to x minus xn. We are neglecting x0, right? Then from that x0 we are subtracting the rest of the index, x0 minus x1, x1 minus x0 minus x2 up to x0 minus xn. So this term is generated by x0, means in the numerator we are neglecting x0 and rest of the xi we are subtracting from x. In the denominator from x0 we are subtracting all xi, and with this expression we are multiplying the corresponding y0. In similar manner you come to the second. In second term we are neglecting x1, means you see here x1 is not there. We are subtracting every index xi from x except x1, that is x minus x0. We are neglecting x1, then x minus x2 up to x minus xn. What we are neglecting? We are neglecting x1. So x1 minus x0, x1 minus x2 up to x1 minus xn. And we are generating this term for x1, so we are multiplying y1. In the similar manner, we write up to the last term. This is the formula for Lagrange interpolation formula. Now we will consider one numerical examples and we will see how we use this formula and how we find the value of y. Now we will consider one numerical. Say we are considering the set of data. The value of x is say 5, 7, 11, 13, 5, 7, 11, 13 and 17. And the corresponding value of y are 150, 392, 1492 and 2366 and the last one is 5202. 5202. Okay, so this is the set of data. Question is find y of say 9. We have to find the value of y at 9, right? First you see, observe the data of x. This is 5, 7, gap is 2, 7, 11, gap is not 2, right? That means the given data of x that are not equispaced, means the difference are not same. So it is not equally spaced data. That is why we can apply the Lagrange interpolation formula here. Okay, that is the most important part. So what is the Lagrange polynomial formula? That is L of x that equal to x minus. Formula says this is x0, x1, x2, x3, x4. So we will neglect the first data. We will neglect first term. And the rest of the data x will be subtracted from x, that is x minus 7 into x minus 11 into x minus 30 into x minus 17 divided by. Okay, in the numerator, in first term we are neglecting 5. Then in the denominator, from that 5 you subtract rest of the x, that is 5 minus 7 into 5 minus 11 into 5 minus 30 into 5 minus 17. So this is the first term. With this you multiply the corresponding data of y, that is 150. Okay, so that is the idea. So first term is over. Then next term plus. In next term we will neglect this 7. That means x minus 5. Next term we are neglecting 7, that is x minus 11, then x minus 30, then x minus 17. Okay, so we have neglected 17. So in the denominator you subtract every digit of x from 7, that is 7 minus 5 into 7 minus 11 into 7 minus 30 into 7 minus 17 into 392, because corresponding data of y for 7 is 392 plus. Then we will neglect third term, that is x minus 5 into x minus 7 into x minus 30 into x minus 17 divided by, we have neglected 11, 5 is there, 7 is there, 11 is not there, so you write 11 minus 5, 11 minus 7, 11 minus 30, 11 minus 17, and corresponding to 11 the data is 1492. Okay, so 11 is over. Then consider 30, x minus 5, x minus 7, x minus 30. For this term we have neglected 5. For this term we have neglected 7. For this term we have neglected 11. For this term we have to neglect 30. That means here we have to write x minus 11 and x minus 30 we have to neglect x minus 17. Right? Divided by, we have neglected 30. So that is 30 minus 5 into 30 minus 7 into 30 minus 11 into 30 minus 17 into 2366 plus the last term. Last term we will neglect 17, that is x minus 5 into x minus 7 into x minus 11 into x minus 30 divided by, we have neglected 17, so you write 17 minus 5 into 17 minus 7 into 17 minus 11 into 17 minus 30 into corresponding data is 5202. Okay, so this is the formula of Lx for x, right? We have to find the value of y at 9. We have to find the value of y at 9. In this formula, wherever x is written, just you write 9 and simplify. Again I am repeating, in this formula, wherever x is written, here x is written, wherever x is written, in that place just you put 9. So put value of x is equal to 9 here and simplify. If you put the value of x as 9 in the entire expression and you will simplify, you will get the result, that is 810. That is 810. Okay. So this is the idea that how we apply Lagrange interpolation formula to find the value of y for a particular x. The x is given from 5 to 17 and 9 is within that 5 to 17. That is why it is called interpolation, and for 9 we are calculating the value of y, right?